Here's the solution to quiz number 1 for ECE 321, Analog Electronics. The first problem is to write 7 equations for 7 unknowns for this op-amp circuit, where R is based upon your birth date. What I would do is first start with the easy equations. At the op-amp with negative feedback, V plus equals V minus, so I know right away V2 equals 1. I know that V3 equals 2. And I know that V5 equals V6. So that's 3 equations. I now need 4 more. The next 4 equations would just be conservation of current. At node 1, I can't write the equation because I don't know what this current is. Plus, I already wrote it. The node equation of V1 is V plus equals V minus. At node 2, I can write the equation. Current up plus the current down plus the current left equals 0. The current left is equal to 0. So just current up plus current down equals 0. V2 minus V1 over 3K plus V2 minus V3 over R equals 0. At node 3, current up plus current down plus current left equals 0. There is no current into the input to the op-amp, so it's V3 minus V2 over R plus V3 minus V4 over 4K equals 0. At V4, again I don't know what this current is, so I can't write that equation. Plus I already wrote it, that's V plus equals V minus. At node 5, current left, current right equals 0. And node 6, current right plus current left is also equal to 0. It gives you 7 equations, 7 unknowns. This one you didn't have to solve, just write the equations. Problem 2. Find y as a function of a, b, and c. Now if you notice, this right here is a non-inverting amplifier. I know that V1 is 1 plus R over 1K times A. It's just supposed to be an R, not an R1. Node 2. This is an inverting amplifier. So V2 is minus R over 100 times A, times B, plus R over 200 times C. And this is an instrumentation amplifier. Y is equal to 3, the ratio of the resistors, times the difference, V1 minus V2. The one going in the plus side is the adds, the one going in the minus side subtracts. Substitute, I have y as a function of A, B, and C. Problem 3, design an amplifier that has a gain of 4 plus 2A plus 3B. And there's many ways to do this. Gotta have a voltage source. So let's assume I have a 10 volt source. It could be anything else you want. If I assume 10 volts, then I'll have X is equal to 0.4 times 10, that's 4 volts, plus 2 times A plus 3 times B. Add up the coefficients, I get 5.4. So divide it out, so if these terms are all 10 volts, the answer is 10 volts. Then Y is 5.4 times X. To do X being the weighted average, I have my 3 inputs, 10 volts, A and B. A has a weighting of 2, so pick your favorite resistor. I chose 10K with a weighting of 2. B is your 10K with a weighting of 3. Your 10 volt is your 10K with a weighting of 0.4. Those are the 3 resistors, so X is the weighted average. And then Y is 5.4X, so this is a 4.4 to 1 ratio with a non-inverting amplifier. There's other ways to do it. This is one way. Problem 3. Design a circuit where the gain is for minus 2A minus 3B. Again, many ways to do that. Again, I'll assume I have a 10 volt input. So this gives me 10. This is the gain of minus R1 over R2 minus 0.4. Gives you minus 4 volts. I'll now have Y is equal to negative 2A minus 3B minus 4. So this is a 1-to-1 ratio. Gives you gain of minus 1 or gain of plus 4. This is a 3-to-1 ratio. So gain times B is minus 3. 2-to-1 ratio. Gain times A is minus 2. So this is one way to build 4 minus 2A minus 3B with a 10 volt source. Again, there's other ways to do it. This is one way. Problem 5 is find the voltages and currents. So if the input is 5 volts, V plus equals V minus, this is also 5 volts. This is 5 volts. If this is a diode with a 3 volt drop, this makes V3 2 volts. And if there's a 0.7 volt drop across the transistor, this is 5.7 volts. And this one's off, this one's on. It's actually active region. In terms of currents, 2 volts, for me this is 1414 ohms, depends upon your birth date. 2 volts at 1414 ohms is 1.414 milliamps. That's I5. I4 is I5 over beta plus 1. So that divided by 31 gives you I4. That's your I5 over beta plus 1, or divided by 31. And the last problem, if I take this wire and move it from here to over here, what happens is, with negative feedback, V plus equals V minus, V3 is now 5 volts. The diode is turned on, it's got a 3 volt drop across it, making V2 8 volts, plus 0.7. This is now 8.7 volts. The current, 5 volts over R, for me this is 1414 ohms, depends upon your birth date. For me it's 3.53 milliamps. This is the I5 over 31, 114 milliamps. In kind of spirit of it, this would be a current amplifier. When I specify the voltage, I'm specifying the current, and this is whatever it takes. This is a voltage amplifier. I specify the voltage right here, and the current then drops out. Where it really shows up is if this is 2 volts. 2 volts is enough to turn on the LED, so I have no output. If this is 2 volts, I still have current flow, and the current will all be proportional down to 0. This is whatever it takes to set the current. That's quiz number 1 for ECE 321, Analog Electronics.